Hi, Algebra 2. I'm going to teach you how to use the quadratic formula today. So here's the quadratic formula. I think that everybody needs to learn it because I just looked at the SAT guide and it is definitely not a formula that is given on the SAT. And I learned it a long, long time ago to the tune of Row, Row Your Boat. No, anyway, here it goes. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That's Pop Goes the Weasel, by the way. So anyway, say that a couple of times in your head and you will have the quadratic formula memorized. In order to use it, your function has to be in standard form. Standard form is always ax squared plus bx plus c. So this b comes from the number in front of x. There's a 4 there, we'll use that. The a comes from x squared's coefficient, and then that c right there comes from the constant. It is important that an equation is written in standard form before you use the quadratic formula. Number 1, it has to be equal to 0. So it says, what are a, b, and c in this equation? I do not know because it is not in standard form. So my first move would be to add 2 to both sides. So that leaves me with 12x squared minus 11x plus 2 equals 0. Now I know that the number in front of x squared is a. So I'm going to jot that down. A is 12. B is always the number in front of x. You have to take your sign with it. So b equals negative 11. And then c is the constant, which is 2. So c equals 2. Once you know what a, b, and c are, now you can just plug the values into the quadratic formula. Instead of saying negative b, it's helpful to say the opposite of b, because when you have a negative in front of a number, it takes it and it changes the sign. So if your b is negative 11, it's actually the opposite of this, which is positive 11. Plus or minus square root. B is negative 11. B, this b squared term, you should always, always, always put with parentheses because it will make your calculations more accurate when you put it in the calculator. It says minus 4ac, so that says, hey, take negative 4 times the a times the c. Negative 4, a is 12, so sub that in, and c is 2, so I'm going to sub that in. It is all over, so from the 11 through the end of the radical, 2, and then a is 12. The stuff under the radical, we're going to learn, it's called the discriminant. You should plug that entire thing into your calculator all at once. Here's what it should look like. You need to start it off with a parenthesis. If you don't, you're going to get a wrong answer. Negative 11, close parenthesis, and then you're going to square it, and then you're going to hit the subtraction button, 4. You can either use times button, or you could use the parenthesis if you wanted to. The times and the parenthesis all tell the calculator that you're going to multiply it. You hit the enter key and you get 25. So x is 11 plus or minus radical 25. All I did was calculate the number under the radical. I have not taken the square root of that number yet. And 2 times 12 is 24. If the number under the radical is a perfect square, now is the time to take the square root of it. So the square root of 25 is 5. This plus or minus gets me two answers. The plus or minus gets you two answers. I'm going to rewrite it. One of the answers is 11 plus 5 divided by 24. And the second answer is 11 minus 5 divided by 24. 11 plus 5 is 16 divided by 24. You could put that into your calculator or you could reduce it. I put it into my calculator and I got 0.625. I just learned a couple of things about the SAT that many of you will find helpful. The first thing that I learned is that if there's a part where you have to write your answer out, it will take a fraction or it will take a decimal. The other thing I learned is that your fractions actually do not have to be fully reduced. And the more times you try to simplify a fraction, the more times you might make a mistake. So if you were taking the SAT right now and it said, what is the positive answer? I would either write it as 16/24 or 0.625. Either one of those would be a good answer. And 11 minus 5 is 6 divided by 24. And that decimal is 0.25. In your youth, we kept telling you to reduce your fractions. And now, when you're getting ready to take a standardized test, we say don't. Number 1 is going to be just like the problem that we did, so let's not do that one. Let's skip to number 2. You should probably do number 1 and check my notes online. The equation has to be set equal to 0. So I'm going to subtract 1. I get 4x squared minus 1 equals 0. So if you look up here, a is always x squared's coefficient, so we have an x squared. B is x's coefficient. Ooh, we do not have one. So if you do not have one of your terms, you need to sub 0 in for it. So I'm going to rewrite this as 4x squared plus 0x minus 1 equals 0. Now I have all three terms. Now I can see that a is 4. I can see that b is 0. And I see that c is negative 1. I have the formula up above, even though it's not in view, so I'm just going to sub everything into the quadratic formula. X equals negative b, so b is 0, plus or minus square root b squared, so I have 0 squared, minus 4 times a, which is 4, times c, which is negative 1, all over 2a, so that's 2 times 4. Having the 0 out in front, it's not necessary to rewrite that. It is necessary to keep that plus or minus out in front because I do generally get 2 answers. I ran these numbers into my calculator and I got 16. It shouldn't have been that long. So 16 is a perfect square. We're going to take the square root of 16, which is 4. I know I just told you not to reduce it, but I think we could all reduce 4/8. So this answer is plus or minus 1/2. We get 2 answers. You get a positive 1/2 and you get a negative 1/2. So the plus or minus out in front is what gets you your 2 answers. Let's go with number 3 next. There we go. So my first move is to add 10 to both sides so that I can have it in standard form. If there's no number in front of x squared, it is always an implied 1. So I know a is 1, b is -6, and c is 10. I'm going to plug this into the quadratic formula. The opposite of b, so the opposite of -6 is 6, plus or minus the square root of b squared, so you want to be sure you put parentheses around that, minus 4a sub 1n, c sub 10n, all over 2 times 1. So I get 6 plus or minus. The number under the radical is -4. All right, so now here's where we need a mini lesson. If you have the square root of -1, the square root of -1 is I. This is an imaginary number. Imaginary numbers are part of the numbers that we use in math, but an imaginary number cannot show up on a graph. So anytime that you get an imaginary number, I'll show you this in a minute, you get an imaginary number because what we are finding right here is where the graph crosses the x-axis. It is possible that the graph either opens above the x-axis, in which case there's no solution because the vertex is above it. Or it opens down, and that's because the vertex is below the x-axis. So when we are solving these solutions are the x-intercepts. And so what we are really finding here is where the graph is crossing the x-axis. If you get an imaginary number, that says, hey, this equation doesn't cross the x-axis. All right, so I'm going to teach you how to simplify this. So I have 6 plus or minus. If the number under the radical, that part of it, if that is a perfect square, you go ahead and take the square root of it. So the square root of 4 is 2. And then the square root of this negative portion is I. All over 2. This is a fraction that can be reduced. So when you reduce it, you have to divide each of the terms in the numerator by the denominator. So 6 divided by 2 is 3, plus or minus, and 2i divided by 2, so the 2's cancel each other out, and you just get I. So this is actually what we call a complex number. So the only thing that we have to learn how to do in Algebra 2 is to, when you see a negative under the radical, you have to be able to change that into an I, and then you should be able to reduce these fractions. And that is about the extent of it in Algebra 2. In pre-cal, we do more with imaginary numbers. We add them, subtract them, multiply them, and divide them. Let's try number 4. Oh, at least it's in standard form. So there's my A, there's my B, and there's my C. I highly encourage you to label them. Either write them out like this, or at least write them below the numbers. X equals negative B. Right, so the opposite of 5 is -5. Plus or minus square root b squared, so I have 5 squared, minus 4a, plug 3 in, c, plug 4 in, all over 2a, which is going to be 2 times 3. So all I did here was labeled a, b, and c, and I did direct substitution into my quadratic formula. The next thing you need to do is you need to take the numbers under the radical, and once again, this is called the discriminant, and figure out what is that number. So x equals negative 5 plus or minus. You should get negative 23 all over 6. There's not much simplifying that we can do here. Anytime you have a negative under the radical, we are going to get in the habit of changing that to I to show it's a complex number. So I have negative 5 plus or minus I. 23 is not a perfect square. We can't take the square root of it, so that just stays a radical 23 all over 6. In this case, this is my good final answer. In the one before, I noticed that every numerator was an even number, and I could simplify that. I could just divide it by the denominator. In this one, 5 divided by 6, that doesn't divide evenly, and that doesn't divide 6. And by the way, numbers under the radical and numbers not under the radical, those are in two different families of numbers, radicals, and these regular numbers, they never, ever, ever simplify each other. I'm going to stop right now and make another video for the backside.